Hi guys, and welcome back on my channel. In this tutorial I want to show you how to make this a useful tool for modeling. First of all, I'm going to discuss what it is, how you can use it, and how you can create it. So let's dive in. Now I'm working with Blender version 4.5.0, and this little tool could seem a stupid tool, but I think you can use it in some way for modeling. So first, what is it? This is a set of three planes, and you can easily enable or disable the three planes for each couple of axes. You can increase or decrease the extension of these three planes. There are grids and there's no faces inside, so you are seeing only edges and vertices. You can see from this viewport shading. You can change the shape of these planes, so you can choose cube or sphere if you prefer. You can increase or decrease the resolution of this part. And what is this resolution? So it's the length of each square based by the unit measure used in your scene. Anytime you can increase the subdivision if you need. You can rotate the local axis of this geometry on the Z, on the Y, and on the X axis. Then you can enable or disable this only front to hide the edges and vertices behind the parts you're looking through the camera, and this is very important. So if you enable or disable this feature, it can work only if you are seeing your environment from the camera. You can see through this red dotted line. So if I go out from this perspective and enable this feature, you can see these only work in this way, because until now Blender doesn't allow you to get the information of the location and the rotation of the 3D viewport point of view in geometry nodes if you are working with modifiers in geometry nodes and not in tool. So in this case we are working with a real modifier. And finally we have this particular feature, follow target, that I'm going to discuss directly in a real application. Second, how you can use it. So imagine you have a mesh like this. I'm going to press Shift A, mesh and icosphere. I'm going to increase the size of this icosphere, and maybe you want to create some mesh and other object inside this little face. So you can take this guide, you can enable from this menu the align rotation to target and enable, for example, the face snap. We can press G to move and enable the snapping tool with the control button and click on this face, and you can see this snapping feature. Now we can disable this align and set the snapping on the vertex and move these on this vertex. We can rotate these planes using the rotate tool with R and Z to enable the snapping on the Z axis, but not the global but the local Z axis. And you can see these repeating the pressing of the Z, and you can see this is the local Z axis, and pressing B to take one vertex from this grid, pointing here, for example, on this vertex. And now we have this particular alignment. We can increase the extension of this grid a little bit. We can increase the resolution by 3 millimeters or other resolution value. And now we can start to create and add geometry in our scene. So for example, I can press Alt A to deselect everything, press Shift A, mesh. I can create a plane, G to move, Control press to move the plane here, go in edit mode and press M to merge all the vertices in one place. So I have only one vertex in this moment and here in this point of this grid. And what I can do is to enable the vertex snapping, and now selecting the vertex selection, we can select this vertex, press E to extrude, and pressing the Control we can directly create a new geometry without using the rules, the measures, or manually entering the value on your keyboard, so selecting directly the final point for the extrusion. So in this case, I want to move these 5 units here. Maybe I want to have not a sphere shape here, so I can select the cube and extrude another time here, extrude like this, extrude another time, extrude here, and I can move these a little bit here and extrude last time here. And as you can see, we have a perfectly aligned shape and geometry with a correct proportional distances between these vertices, and you can see the beauty of the result. Now, why this only front? Because if I disable this check, you can see it's more difficult to find the correct point on which I want to snap. So maybe I want to take this point and press extrude, and the control can snap not only on the plane parallel to this face I'm working on, but also to the plane perpendicular to this face. And maybe I don't want this behavior. So to disable this behavior, I need to select this only front. And in this case, I need to go in the other part, in the other side of this view, and start again to snap the vertices. But what if I want to go out from the face, so perpendicular to the face? So maybe I need to have a tool that follow my extrusion and can locate and place itself on the last vertex I extruded to allow me to choose another axis and a plane to work. So to do this, I can easily select this follow target, and you can see this warning. If you don't have any vertex to let this feature work, select with this eyedropper the new plane I'm working on. You can choose the offset index that as a default has -1, because if you extrude an index, you have a new index made by Blender, so a new bigger index in the system. So you need to have this tool on the position of the last index. I need to change and position in the space -1. For example, if I delete this vertex, you can see this is the last extruded vertex, and before I had this. So now if I take this last index and extrude these, and I want to go perpendicular to this point, I can do it, and I can press G and move using the control, and then use the extrusion and go up, okay, perpendicular, as you can see here. And then I can go again on this direction, pressing extrude another time and go here. And maybe I want to go and place the new vertex diagonally like this, and maybe another time in this plane, so parallel to the original face I started to work like this. Maybe you want to go and move this new vertex not by 3 millimeters, but 4 millimeters on this way, so you can change the resolution like 4 millimeter, press E to extrude, and now you have a new reference distances on these planes. If you change the offset index, you can go and turn back on the previous made vertices to continue your work. And anytime you can disable or enable the local plane, and anytime you are able to deselect this follow target and move this plane where you need. So for example, if you need to rotate this plane by 45 degrees, you can take this local z-axis and increase by 45 degrees, and now you have a perfectly angle here of 45 degrees between this line and this edge of the triangle face. Now let's make it from scratch. I can press the Shift A, create a plane, go in the geometry nodes workspace, or press the plus button, general and geometry nodes. I exit from the view of the camera, press Ctrl I to invert the selection of the objects in the outline, and press H to hide. I select this plane, Alt G to reset the position, and press New to create the new modifier. We can call it Grid Guides. You are seeing a point 001 because I already have the modifier inside the scene. And now, first step, we need to use a grid to define the planes we want to show in this environment. We can start making a grid, link this in the group output, and we can use 2 vertices for the X and 2 vertices for the Y. Press Shift Z to see the final result. We can press N to see the sidebar, go to group, and we need to add 3 Boolean parameters to define what plane we need to show. So an input, YZ plane, and this is a Boolean. We can duplicate it twice and rename it in XY and XZ. We can check them as the default, okay, and the structure is a single, so we don't need to use any attribute inside these parameters. Now we need to add another parameter for the resolution, okay, so the size of the square inside these planes, this is the resolution. It's a float number and the subtype is a distance from 0, and this is a single attribute. And now we can easily link the resolution here in the definition of the grid. In this way we can set, for example, 1 millimeter, and here it is, a single face 1 by 1 millimeters. I tried to use only this grid to subdivide multiple times and get the correct relationship between the number of the squares and the size of the entire plane, but I found some glitches in the environment playing with the correct and calculating the correct size X and size Y. So I preferred to use a single node grid and found that the duplication of this node is more reliable. So to avoid a particular problem with the calculation, we need to set a minimum of non-zero but 0.001, a very little number but not 0, because then we are going to use this value in a division, and you know that in Blender or in whatever application you need, you can't divide a number by 0 because maybe the system can explode. So we need always to avoid this behavior, and to do this I need to set here a minimum tolerance, okay, and a minimum value you can tweak if you need. Now that we have the single square, we need to duplicate this grid a number of times to make one row of squares, and then duplicate this row to have the entire plane of these couple of axes. So first of all, we need to add the duplicate element node, and we need another parameter, so an extension parameter. So we can use the extension parameter that is a float and subtype a distance, again minimum of 0, and this is a single value. We can move it a little bit up in this menu and change these duplicate elements from a point to face, because we need to duplicate a face. Now if I link directly this extension here in the amount and try to set here 2, for example, you don't see anything. Why? Because now I'm using the unit measure of my scene, and inside our parameter you need to take care of this value, because inside Blender there is a relationship between the unit without a unit measure and the meter in this case. So the value of 2 millimeters is 0.002 in meter, or in the basic scale of the unit used inside Blender. So for this reason you need to multiply this value by 1000 to have an amount of 1, okay, so to have one face. In our case the extension is not exactly this value multiplied by 1000, because the correct number of the squares duplicated is the extension divided by the resolution. So if I have 1 millimeter and 1 resolution, I only want 1 square. If I have an extension of 20 millimeters by 1 millimeter as a resolution, I want 20 squares. And if I set 5 millimeter of resolution, so the size of a single square, I want to have a total of 20 millimeter divided by 5 millimeter as a resolution to get the correct number of squares inside my row. Okay, this is the correct number. So I can start to divide the extension by the resolution of the single square and use this for the amount and drop this. Now we can move these duplicate elements in the space using the set position tool, and because we have this special duplicate index that is commonly used and linked inside the duplicate element, so for each face we have a special index, we can use this to move each face by a value on the y-axis or the x-axis. And I can prove you, because if I press Shift Ctrl and click one time and another time, you can see inside these faces we have this duplicate index, and if I change the domain in point and we go in the vertex, you can see the 0 index of the first face is commonly used for the first 4 vertices of the mesh. Then we have the index 1, commonly used for the next 4 vertices, and so on. So if we take this set position that works in the point domain, we can use a combine XYZ, link this in the offset, use for example the x-axis to make the row, and multiply this duplicate index and what? The resolution itself, so the size of the single square. So in this way, if I connect the resolution inside this multiply and press Shift Z, you can see we have 4 faces. The first face has 0, 0, 0 and 0 as the index, so all the zeros multiplied by the resolution of 5 millimeters move all these 4 vertices by 0 on the x. The next 4 vertices are moved by the index of 1, 1, 1 and 1 by 5 millimeters, and you can see these shifting and so on. But there is a problem. I press H to collapse, press H to collapse. As you can see, the original coordinate system of Blender has an origin point here, and from this point the system starts to make all around the resolution of the little squares. So we need to do the same. And if I, for example, set a resolution of 4, we have 5 squares in this row, but the center of the entire row is here, is in the middle of a square, and we don't want this. We need to have an origin point at the center, and from this point start to have the correct plane and squares around this origin point. And with an odd number of squares we cannot get this result. We need to calculate the correct number of squares based by the division between the extension and the resolution. So if the division of these 2 parameters is an even number, okay, it's perfect, because if I set here 5, we have the center here on this edge, and from here the system starts to make the squares on one side and the other side. If I set 10 millimeter, perfect, we have only 2 squares, but the center is always on this edge. But if I have 4 millimeters, we have a problem. So if the division of these values and in the detail the truncated value, okay, so we need to cut off the digit part of the number. If this division, so in this case 5 millimeters, has a module with 2, so the rest of the division between the original number and 2, and this equal to 0, we have here the result of the even number. So 5 divided by 2 is equal to 2 with a rest of 1. So we have an odd number because the rest is not 0. In this case, if we want to have an even number, we need to calculate the module, so divide the number by 2 and ask if the rest is equal or not to 0. If it is equal to 0, this means we can directly connect the value of the output of this truncate, because as you know, we cannot use a value of amount in float, but only in integer. So we can directly link these in the amount, and in the false condition, as we can see in this moment, we need to take this truncate value and add 1 to make it even and not odd, and link this to the false. So I need to add 1, and as you can see, 20 divided by 4 is equal to 5, but I need to add 1 to have a perfectly row designed and have the center always on an edge to start with the square on a side and on the other side. Now I can press H to collapse these nodes, H to collapse. I can move these nodes a little bit. I can drop this viewer. I can add another time the group and link the resolution in this multiply like this, and now is more clear. Now we can take this output and duplicate another time the faces, but going on the other axis, so the y-axis, to make the entire plane. So we can repeat this step and take these 5 nodes, press Shift D to duplicate them like this, and we can connect this set position here and the set position in the group output, and use the same amount used for the first duplicate elements to the second duplicate elements, but using the other axis, so not the x but the y axis. And here we have the result of the entire plane with the perfect origin point in the center, always. Okay, if I set 5 millimeter, I always have the center here. If I set 3 millimeter, for example, we always have the center here. And it's very important to be able to increase or decrease the extension of this grid touching these parameters. Now let's set 20 millimeters, and we can select all these nodes, press F, create the grid. Perfect. Next step, we need to move this grid to the origin of the entire object, because we have the origin point of the object in the global origin point, and you can see it pressing N and looking the location here. So we need to shift all these, and to shift these we only need 2 things: the entire size of the square of the plane and this little size. Okay, so what we can do is to take the entire object, calculate the bounding box, and shift by this distance, so the half of the entire x in size, the same in the y-axis, and subtract the resolution of the single square divided by 2. Okay, because we don't need to move by this part, because the object is already shifted by this half size in the x-axis with this little negative value, and on the negative y-axis by this little negative value. So we can press and find the bounding box. We can go here, link with the Alt and right drag, and we can subtract from the max the mean value to get the entire vector of the size, okay, from here to here. Okay, the most negative position of the bounding box and the most positive. Next, we can separate this vector in the 3 components. Press H to collapse, H to collapse. We can use the transform geometry. We don't need to use the set position because we need to move the whole object, not a single element. So we can link these a combine x, y, z, and take the size in x, divide it by 2, multiply by -1 because we need to go in the opposite direction of the axis. As you can see, we have the object on this positive plane in x and y space, and we need to go in this direction, okay, in the negative direction for both of these 2 axes. So we need to multiply by -1 and use this in the x and in the y axis. But remember, we need to subtract from this value before going in the multiply. We need to subtract the little piece of the half of the resolution of the square, so this piece and this piece of the number. So we need to take the group input again, take the resolution, divide it by 2 like this, and link this in the subtract using this value in the multiply. And you can see the result, because now I always have the object centered in the origin point of the object, even if I increase or decrease this extension or increase this resolution. Okay, we can select all these nodes, press F, Shift to origin. Next step, we can control the shape of this big square. So instead of using this entire number of little squares, we can delete some faces. So we need to add another input, and in this case this input is a menu. So we need to change this in menu, and this is the shape. We can add here the menu switch, a beautiful node in which we can select it, go in the node and choose the shape, so cube or sphere. We need to add the group input again because we need to link this menu switch here in the shape menu. Go in the group section, and for the default selection of the menu we can select the cube. This is a single value, and we can select from this shape the cube, and we can use this expanded check. This is the first time I think I use this check because it's more cool, I think, to show it in this way instead of using the classical combo box. Now for the cube shape it's all easy because we only needed to link this original geometry we are already seeing in the menu switch and link this in the output. But if I select the sphere, I need to change the shape. So to make the sphere or the circular result, we can press 7 for a moment, and we can imagine this shape like this. Very ugly, but you can understand. And what we can do is to delete all the faces that have the distance between the location itself and the origin point greater than what? The entire bounding box divided by 2. So in this case, the distance between this point and this point is okay, because it's equal to the half of the entire bounding box. But if I go in this zone, you can see we have this point that has this distance greater than the half of the entire bounding box. So in that case, this point will be deleted. We can work with point or faces. In this case, I want to use the face because we have more control for the result. So what we need is to take the position of each face and delete the geometry here, selecting not the point but the faces that have the position. And I remember you, the position is always calculated from the element itself and the local origin point of the object. So we have this information free, because if I mute for a moment this delete geometry, if we take this position for this face is already the vector between this point and the origin point. If we take the position of this, is already the vector between the center of the face and the origin point. And the same for all these faces, without adding any calculation inside this workflow. So we can easily take the position, calculate the length, and ask if this length is greater than what? The entire bounding box, okay, taking only one component, the x or the y, as you want, divided by 2. So again, we can take the bounding box, make the subtraction between the maximum and the minimum to get the entire diagonal vector from the minimum point and the maximum point. We can separate this vector in the 3 components to get the total x component and the total y component and the total z component. Take the x, multiply this by 0.5. As you can see, sometimes I use the divided by 2, and sometimes I use the multiplication with the 0.5 to add an habit on your routine and better learn. This kind of calculation is the same and gives us the same result. And now, if the length is greater than this particular value, we need to delete this face. And if I enable this delete geometry, this is the result, okay? Not so hard, so we can delete the annotation, and this is the final result. And we can link this delete geometry not in the cube but in the sphere. So I need to take this menu, move this up, create a reroute for a moment, and link the deleted geometry here in the sphere and the original in the cube, like this. Link this reroute in the delete geometry, and this is the changing of the shape. I decided to write this part of the workflow before the duplication of the plane for the other planes, because we have in this case a less number of polygons to work with, and we can increase the performance a little bit inside Blender. We can select all these nodes, press F and set shape. Next step, let's make the other planes, and this is very easy to do because we can take this result and use the transform geometry 2 times, 1 time, and shift D and duplicate, rotate 1 time on the Y direction and 1 time on the X direction, and join all together. So we can join with the shift control and right drag here, and we can join with the original, and we have the 3 planes. But before joining these, we need some switches to enable or disable this viewing. So we can add the group input another time and ask if I want to see the X and Y plane in a switch, and we can duplicate this twice, move the join here, and we can make a reroute here and a reroute here and go down, because in this way I can easily link these here, this here, and this here. So if I want to have the X and Y, so the first plane we made, so this line, I can link these in the true, or otherwise we don't need any geometry and we can link this in the join geometry here. The same for this result, if we want it, and link here in the geometry and drop this line. We can drop this line, we can drop this line. And if we want to have this result, so the Y and Z, so this plane here, okay, that is the original rotated on the Y axis by 90 degrees, we can link these in the geometry. Press H to collapse, H to collapse, H to collapse another time. And now if I enable each of these plane, you can see the result inside our viewport. And remember, in this moment, we still have faces. So if I press Shift Z another time, we still have faces and we don't want them at the end of this tutorial. Now we can select all these nodes, press F and set planes, move this a little bit. Now, next step, we can merge all the vertices together, but not using this very high number of distance, but 0.001, for example, to decrease the total number of vertices and have a very clean geometry. So as you can see, if I mute these, I have 3,800 vertices, and width we have near 1,000 vertices. Now we can add the other features, so the subdivision. So we need to add another input parameter as an integer, and this is the subdivision from 0, and this is a single structure type, and we can add another group input here and add a subdivision mesh, not surface, because we don't want to smooth the surface but easily subdivide each face by 4 for each level of subdivision, and we can link this subdivision like this. And this can be useful, for example, if I have a resolution of 4, okay, you can use this subdivision to increase rapidly the number of subdivision, so 4, 2, 1, and so on. Next step, the rotation. We can add a vector to have a local rotation on the axis, because maybe you need to rotate it after the rotation of the object. So remember, this kind of rotation will affect the elements themselves and not the object itself that has the own rotation, okay? And this is why I snapped the object, aligning it on the face of the icosphere, and then I used the local X rotation to rotate it by 45 degrees in the example at the start of this tutorial. So in this case, remembering the tutorial of book of rotation I made for this purpose, we can get the actual position of each element and rotate this vector by a rotation and override the position by the same position in the space rotated by a value. Now this works perfectly without any other calculation because we have the relationship between the position of each element with the origin point. So we have a balance between each element and the origin point. So for this reason we can only use this single rotation, and we can change the type in vector like this, subtype Euler angles to have degrees here, and we can take the group input another time and link directly the local rotation in this socket. That I remember, Blender converts these values from vector in rotation, okay, so in degrees in this case. And I remember you in the modifier you are seeing degrees, but Blender starts to convert these in radians to use them inside this point, and you can see the difference because if I set for example 45 degrees like this, here we have 45 degrees, but with the mouse you can see pi divided by 4 as the result in radians, and then it converts again the radians in degrees, so 0, 0, 45, and then apply the rotation on each position. Ctrl H to collapse and move this a little bit. We can select all these nodes, press F, local rotation. We can set these as a single structure type. We can move the shape before the resolution, I forgot it. Now the tricky part, the hiding and deleting of the faces behind and the points behind the point of view from the camera. So to understand this trick, I enable for a moment the camera so we can see it, and I move this a little bit because the idea is this. Imagine to create and make a ray that starts from each point of our geometry and go through the origin point of the camera. So for example, for this point we have this ray, for this point we have this ray, but not only for these 2 points but also for the point behind that we want to delete, we can start with a ray through the camera. Now what happens is that for these 2 points we have a ray that doesn't intersect any other part of this geometry but this point. So for this point we have an intersection here, okay, and if we have an intersection we have a hit, and if we have a hit we need to delete this point. So first of all we need to calculate this ray starting from the position of the elements going through the camera. So to calculate this vector for each element we need to do a little calculation in a vector domain, that is this. We have the global origin point here, and we have the location of the camera, that is this. We have the position of the element, that is this vector. To have the difference between these 2 vectors, we need to take the location of the camera, this vector, subtract the vector of the position of each element to take this vector as the difference, okay? And this vector needs only to get the direction of the ray. Next, we are going to take this direction to make a full ray between the position of the element through the camera, and if we have an intersection with the geometry itself, we need to delete that element, that point. So let's start step by step. We need to take the active camera. From this active camera we can get the object info and select relative to follow the changes of the location, rotation and scale of this camera. And what we need is to subtract to this location what? The position of each element, of each point. So we are going to add here, it's obvious, delete geometry. I'm going to mute for a moment, leaving this in the domain of a point because this position needs to be got in the point domain. So in this way, from this output we already have all these vectors, okay, all these Azure vectors. Now from this we need to normalize this vector to have a length of 1, okay, in the length, and now we can use the raycast node, create a reroute and link the geometry to intersect it with itself. So the raycast is very useful to emit rays and get the heating and the position of the normal of your elements. So in this case, the source position will be the position itself of each element, and we need to emit these rays from these positions using what ray direction? The direction of this result, so this is subtraction, and it doesn't mind if you want to link the normalized or the denormalized vector, it doesn't mind. And for the ray length, we can use, for example, the distance between each element and the location of the camera and multiply by 2 to be sure to have an intersection between one element and an element near the camera, so between the original point and the camera. So we can get this subtraction, calculate the length and multiply this length by 2 or less as you want, not above 1, because otherwise you are starting to emit a ray from the point to some other position before the location of the camera. This is not a good technique, and now we can link this. Now if I enable this node and link this is heat, so if I have an intersection between the element and other elements inside the same geometry, we need to delete these points, and this is the result, okay? No points at all. Why? Because where you are using the raycast, using the geometry, emitting the rays, intersecting with the same geometry, we have a paradox, because each element that stays on a geometry, if emit something to intersect with some other parts of the geometry, is already touching the geometry itself, because it is the element itself on the geometry. So in the moment where the ray starts, hits in the same moment the element itself. So to avoid this problem, we need to take the source position to emit the ray, okay, and move a little bit away from the geometry, okay, away from the element itself, to not have an overlap of both of these two positions, the source position and the hypothetic heating position. So to do this, we can use the same position of the elements. So I can duplicate it with the Shift D, and I can add a little part of this direction, okay, so the ray direction, but a little piece. So to calculate this little piece, I can normalize the subtraction, so the entire vector. In this way we can have a length of 1 commonly used for all the elements of the geometry, regardless the distance between the element and the camera. And next we can scale this by, for example, the resolution, so the size of the square, the little square, multiplied by 0.1. So I can take another time the group input and take the resolution, multiplying it by 0.1, so divided by 10. And why am I taking this resolution and divide it? Because in the intersection with the three planes, we have the little square here and the little square in the other plane. So I don't want to calculate a distance, a shifting of each element too high to not go over another element. So I'm taking the resolution and I'm multiplying it by a little value to shift a little bit in the space and not go hypothetically over another point in the space of the other elements in the geometry. I can link these in the scale, I can use these in the add and move the position here and use this result as the source position. And now the result is much better. As a recap, we are taking from each element the vector through the camera, we normalized the value, we scaled a little bit the vector and move the position by a little distance through the camera, so for example here, and from here starts the ray through the camera, and if this intersects the other part of the geometry, we have the hitting, and if we have the hitting, we can delete that point. Now we need to decide when to use this feature, and to do this we need to add another input attribute here as the only front, that is a boolean value, single struct, default to true. Why not? Only front, add a group input, ask if the only front is true in a switch, and if it is true, we need to link this deleted geometry, otherwise the original geometry, like this. Press H to collapse and Ctrl H to collapse and link this to the group output, and now we can enable or disable this feature. Remember, if you are seeing a bad result like this, maybe you are not seeing the 3D viewport and the scene from the camera perspective view. So make sure to have the 0 pressed to look through the camera. Okay, this is very, very important. We can select all these nodes, press F, Backface, culling, even if I'm using the points, but the meaning is the same. Now for the last effect and the last feature, so the following target feature, we need to go before the backface culling, because since the backface culling feature works in the final position of all the object in relationship with the location of the camera, we need to move the entire object before delete the points. Okay, so before this calculation, so we need to take this part and move to the right a little bit and go in the middle here. To have this feature, we can add another input here, like the follow target, and this can be a boolean. This needs to be a boolean, single value. Another input as the object we need to use for the reference to allow this object to follow the elements of that geometry, and we can set target, and the last parameter there is an integer, and this is the offset index to let the object shift from the previous index and not the last index of the target object. Okay, so the previous or the previous again, and so on. So the maximum value of this offset index is -1, because we need to shift the position from the last index made of the model we are drawing and painting and extruding, etc. We are modeling, and go in the previous or the previous or the previous or the previous. So adding this negative value of the offset. We can start adding the follow target switch, and for this reason we need another group input and ask if this feature is enabled or not using a switch. And in the case of false condition, we need to link the original geometry position, otherwise we are going to use a set position added on our workflow, linking this to the true condition and linking this output in the backface culling feature. I can move this reroute a little bit, and this is the part. Now I'm going to add the target object. For this reason I add another time the group input, and from this target I get the object info node. Please remember to check the relative to let the grid guides follow the local transformation of the target, because in the moment you take the model you are drawing and extruding, etc., and you rotate it, you need to allow this tool to follow the rotation and the location, but basically the rotation of the object, to maintain the coherence of the tool and the model. Now what we need is to take from this geometry what the position of the last index, adding the offset index. So to do this we need to link this geometry to a sample index node, and we need the vector of the position for what index, the last index, and to calculate the last index we need to link this geometry to a domain size node to get the total amount of points or vertices inside this geometry, and subtract 1, because I remember you all the meshes and the elements of a mesh start in the 0 index mode. So the first ID of the element is 0. And for this reason, if we have 4 vertices, we start with 0, 1, 2, and 3. So the last index has the index of 3, or the total number of vertices 4 minus 1. For this reason, I need to link this point count 4, hypothetically 4, subtracting 1 to get 3, so the last index of my elements. And from these, I need to add another value. The offset index I set in the input attribute of my modifier, that is at least minus 1, because I want the previous index. Why the previous index? Because if I extrude a vertex, I need to move the last extruded vertex in the space. Using what reference? The reference, the grid guides tool, placed where? In the position of the previous vertex I already set in the 3D space. In this way, I can move the new extruded vertex in the space using this reference guide. And I can link this in the index socket, linking this in the offset, not in the position, but in the offset. Now we can test it. I can add, for example, a simple plane, scale a little bit, press tab to enter in the edit mode, and I can take this vertex, extrude it in a point in the space, and extrude another time. And now if I take my grid guides and enable the follow target and link and select the plane, you can see the new position of the tool in the exact location of the previous vertex. And to maintain the modifier active in this stack, I can enable the pin here, select my plane, go in edit mode, and anytime I can play with the parameters of my tool without exiting from the editing mode of my plane. And now if I extrude again another time, you can see the replacing of the tool in the space where I want to use the snapping feature on my grids. It's obvious I can disable the align rotation to target and snap on vertex to be able to snap with the G and control on my new planes. Okay, as you can see in this moment, and I can extrude again, and this time I need to go on the X and Y plane, for example, like this. If I increase this index, nothing happens, but if I decrease another time, you can see the tool is going to go in the third last index of the geometry. Now there is a little problem related to the rotation of the original mesh. So if I have this tool like this and I rotate in the space this, you can see the correct snapping in the correct position of the mesh, but the rotation is lost. So if I need to maintain the rotation, I need to take my grid guides, and inside my workflow I need to take care of this rotation of my object. And now I'm in the relative mode. So what I need is to take the position of my elements and rotate this vector by the rotation of my object to maintain the relationship between these two parameters. So I want to add the rotation, the actual rotation of the object on the actual position of my elements. In this way, I can reposition my elements in the space and add the correct offset to place all the elements themselves. In this way, I can select my mesh and I can rotate in the space as I want, maintaining the correct rotation of my grid tools. Anytime free to manipulate the local degrees. And I want to show you another example. It's more cryptic. So in this case, you can see my tool has no rotation related to any face of my model. But if I delete this plane for a moment and add an icosphere like before, and I scale it a little bit, press Shift Z to see the faces. I take my object and I disable for a moment the follow target and enable the align rotation to target and the face snapping. Press G and Ctrl to rotate and position my object like this. You can see the right rotation on the object itself of my guides. And now if I take my icosphere, I take one vertex, extrude it one time and a second time, and I enable the following target, selecting the new icosphere object and selecting -1, you can see the correct position of my guides. But that I lost the rotation of the alignment started from this face. So the relationship of the rotation is maintained if I rotate the object, but the start rotation based by the triangle I snap it to is lost. But I can restore it. I can select my tool and you can see the actual rotation in the space, okay? And if I change this, nothing happens, but I can copy this information in the local rotation of the object already placed in the correct position in the space and with the relationship between its rotation and the rotation of the parent and linked target object, and I can paste these values directly in the local rotation of the object. And now you can see the correct alignment in the space parallel to the original triangle chosen for the alignment. And now I can take my icosphere and rotate in the space as I want. And I can continue to model my mesh, extruding the vertices where I need. So next I'm going to delete these faces. It's obvious to end the tutorial. I can press H to collapse this add node. I can select all these nodes, press F and follow target. Last but not least, we can add a little warning inside this second last feature. A little warning when I don't have any points in the mesh to allow this feature work. So to do this, we need to take the point counts and ask if this is equal to 0. And not only this, we want to the warning if this feature is enabled. So we need to take this group node, the follow target feature, press Shift D to duplicate it, and we need both of these conditions to be true to show the warning. So I can add a boolean end condition, and if both of these conditions are true, I can link these in a warning message, not an error, but a warning, and I can paste this text, so target without vertices. In this way, if I delete the connection between the grid guides and my target, the system will show target without vertices, so it's not able to work properly. Now this part is finished. The last little part is the deleting of the faces inside our grids, because we don't need them. And to do this, we can go here in the group output and delete the geometry last time, selecting here the face and not all, but only the faces of our grid guides. In this way, I can see the shader of my target or mesh I'm working on. I can clean this layout a little bit, deleting the icosphere, selecting these grid guides used for the YouTube tutorial, but I'm going to share with you the original grid guides that contains the same setup that I set with the right mouse button as an asset, as object, and I enabled this setup as an asset directly with the right mouse button here, marking it as an asset. So in this way you can use it and place both of these two elements in the asset browser if you want to drag directly the object, so the mesh that already contains the modifier itself, or in an alternate way you can create your mesh like a plane and add the geometry node asset directly on it to add that modifier in its stack. I think you would use the grid guides because it is more easy to include and append in your project. Another way is to append directly the geometry nodes using the file and append menu, selecting my file or your file if you want to make it from scratch, importing the mesh from the object subfolder or the grid guides from the node tree subfolder. I go into layout and this is the tool. I remember you can download this on my Gumroad page. Thank you guys for watching this video. I hope you like it. I hope you learned something new and some tricks from the raycast node, beautiful node. And if you like my work, please subscribe to my channel. Don't forget to check the bell icon to get all the notifications of my new videos, and see you to the next tutorial. Bye!